Picture this. The world's most dominant hardware company just committed $26 billion to giving away software for free. Not just any software, AI models that could power the next generation of intelligent systems. I'm talking about NVIDIA, the company that controls over 90% of the AI chip market, systematically funding every major open-source AI project you can think of. Why would a hardware monopolist spend tens of billions making sure the software that runs on their chips is completely free? The answer might be one of the most brilliant strategic moves in modern business history. Welcome to Mindcast. I'm Will, and if you're fascinated by the strategic chess moves that are reshaping our technological landscape, you've come to the right place. Today's episode digs into what might seem like a paradox. NVIDIA, a hardware giant, investing more money in free software than most countries spend on their entire tech sectors. But here's the thing, this isn't charity, this is strategy. And by the end of our conversation today, you're going to understand exactly why Jensen Huang and his team are playing a game that's so sophisticated, most people can't even see the board. We're going to explore 3 game-changing insights that explain this seemingly counterintuitive strategy. First, we'll dive into the economics of commoditizing the complement, how making AI software free actually makes NVIDIA's hardware infinitely more valuable. Second, we'll examine the multi-front war NVIDIA is fighting against tech giants like Google, Amazon, and Microsoft, who are all building custom chips to reduce their dependence on NVIDIA. And third, we'll look at the massive economic shift happening right now from training AI models to running them, a transition that could create entirely new industries worth hundreds of billions of dollars. But first, let me blow your mind with just how massive this investment really is. $26 billion specifically earmarked for open-source AI development. That's not their total R&D budget. That's just what they're spending to make AI software free for everyone. To put that in perspective, that's more than the market cap of most Fortune 500 companies. They've created something called the Nematron Coalition, 8 of the world's leading AI labs working together to build frontier-level AI models that anyone can use, modify, and deploy. Let me give you a concrete example of how this works. Mistral AI, the European AI champion, just raised 1.7 billion euros in equity funding. But here's the kicker. They immediately turned around and secured an additional $830 million in debt financing. And what did they use that debt for? To buy 13,800 NVIDIA GPUs to build their own AI supercomputer. NVIDIA invested in the company used that credibility to raise debt, and then spent that debt buying NVIDIA hardware. It's a brilliant self-reinforcing cycle that simultaneously funds open-source development and drives hardware sales. Meanwhile, their relationship with OpenAI tells a very different story. Originally, NVIDIA planned to invest up to $100 billion in OpenAI's infrastructure, a partnership that would have been the largest tech deal in history. But something fascinating happened. That deal completely stalled. Reports suggest Jensen Huang walked away, calling the original agreement non-binding and expressing concerns about OpenAI's financial discipline. The renegotiated deal? $30 billion. Potentially NVIDIA's final major investment in closed-source AI. Think about that. They chose to fund OpenAI's competitors instead of deepening their partnership with the most valuable AI company in the world. So, what's really happening here? This brings us to our first major insight, the strategy of commoditizing the complement. This is one of the most powerful concepts in business strategy, and NVIDIA is executing it at an unprecedented scale. Here's how it works. If you control a critical component in a technology stack, you want everything else in that stack to be as cheap, competitive, and accessible as possible. Think about it this way. If you sell printers, you want computers to be inexpensive so more people can afford to buy printers. If you sell operating systems, you want hardware to be cheap so more people can run your software. NVIDIA sells the most advanced AI hardware in the world, so they want AI software to be as accessible and competitive as possible. But here's the twist. In the AI world, whoever controls both the best hardware and the best software has pricing power that approaches a monopoly. Imagine if OpenAI had a complete monopoly on frontier AI models. They could essentially dictate terms to NVIDIA. Give us cheaper chips, or we'll optimize our models for Google's TPUs instead. Suddenly, NVIDIA's negotiating position becomes much weaker. But if there are 10 equally capable open-source alternatives, Mistral, Llama, the Nematron family, and others, no single software company can leverage that kind of power. NVIDIA maintains control over pricing, while the software layer remains fiercely competitive. And here's what makes this strategy so elegant. Open-source models aren't just cheaper, they're actually better for most serious applications. When enterprises download a Mistral model, they can fine-tune it on their proprietary data, modify its behavior, and never worry about API rate limits or terms of service changes. Try doing that with GPT-4. Open source isn't just about cost savings, it's about control, customization, and avoiding vendor lock-in. This brings us to our second major insight. NVIDIA is fighting a multi-front battle that most people don't even realize is happening. While they're expanding the market through open source, they're simultaneously defending against an existential threat from the world's largest tech companies. Google has their TPUs, Amazon has Trainium and Inferentia chips, Microsoft has Maya, Meta has MTIA. Every major cloud provider is aggressively developing custom silicon specifically designed to reduce their dependence on NVIDIA. Here's the scary reality for NVIDIA. 60% of their revenue comes from just 5 hyperscale cloud providers. If Google successfully migrates all their AI workloads to TPUs, if Amazon moves everything to Trainium, if Microsoft optimizes Copilot for Maya chips, NVIDIA could lose the majority of their business almost overnight. The end users, people like you and me accessing AI through APIs, would never know the difference. We just want our AI to work. We don't care what chip it's running on.
So how do you defend against that? You change the game entirely. NVIDIA's strategy is to make the industry standardize on open-source models that are naturally optimized for their CUDA platform. CUDA is their secret weapon, a software ecosystem they've been building for nearly 20 years. It's the programming language that virtually every AI developer learns first. When researchers create new models, they instinctively optimize for CUDA because that's where they get the biggest audience and the best performance.
By flooding the market with excellent open-source models that run best on NVIDIA hardware, they essentially force competing chip makers to play on NVIDIA's home turf. Sure, you can try to run these models on AMD's ROCm platform or Intel's chips, but you'll face compatibility issues, performance bottlenecks, and a fragmented ecosystem. It's like trying to run Windows software on a Mac. Technically possible, but why would you choose the harder path? But NVIDIA isn't just playing defense. They're also dramatically expanding their addressable market through something called sovereign AI. And this is where the strategy becomes truly global in scope. Countries around the world are waking up to an uncomfortable reality. If your economy depends on AI, but all the best AI models come from American companies running on American servers, you have a national security problem. Think about it from Japan's perspective, or France's, or India's. What happens if there's a trade dispute? What if foreign AI companies decide your country's data privacy laws don't align with their business model? What if you want to build AI systems that understand your local language, culture, and legal framework? Relying exclusively on foreign, closed-source AI creates unacceptable vulnerabilities in critical infrastructure. So countries are building their own AI infrastructure. Japan is investing billions. France is constructing Europe's most powerful AI supercomputer using NVIDIA hardware. India's Tata Group is deploying massive data centers powered by NVIDIA's latest chips. Conservative estimates suggest that sovereign AI could represent $240 billion in new revenue by 2030. That's not replacing existing markets, that's entirely new demand that simply couldn't exist without open-source models. And here's the crucial insight. Sovereign AI is technologically impossible with closed-source models. You can't achieve true digital independence by licensing a black box API from a Silicon Valley company. Countries need the actual model weights, the training frameworks, the data sets. They need open source. NVIDIA has positioned itself as the essential infrastructure provider for every nation that wants AI independence, while simultaneously providing the free software those nations need to justify massive infrastructure investments. The same logic applies to enterprises. As AI moves from experimental projects to core business systems, data privacy becomes paramount. Healthcare companies can't send patient data to external APIs. Financial firms can't risk their trading algorithms being processed by third-party services. Defense contractors obviously can't use cloud-based AI for classified projects. These organizations need on-premise AI factories with zero-trust security architectures. But an on-premise AI factory is worthless without powerful models to run inside it. Closed-source AI companies are extremely reluctant to let their frontier models be downloaded and deployed in isolated environments. Too much risk of intellectual property theft. So, security-conscious enterprises are structurally forced to use open-source models. NVIDIA provides the secure hardware, funds the competitive open-source software, and captures the entire enterprise AI market. This brings us to our third and most fascinating insight, the fundamental economic shift from training AI models to running them. For the past few years, most AI investment has focused on training, building bigger and bigger models. But we're hitting an inflection point. The future isn't about occasionally training a massive model. It's about running millions of AI agents continuously, reasoning through problems, taking actions, learning from results. This is where NVIDIA's open-source strategy becomes pure genius. When you make AI inference dramatically cheaper, and their latest hardware with open-source models achieves 10 times cost reductions, you don't just save money. You enable entirely new applications that were previously uneconomical. It's the same pattern we saw with digital storage becoming cheap enough for everyone to have a photo library, or bandwidth becoming fast enough for video streaming. We're talking about agentic AI systems that make traditional chatbots look primitive. These agents don't just generate text responses. They iterate, reason through multiple solution paths, use tools dynamically, and execute complex multi-step workflows. Companies like healthcare AI provider Sully.ai are reporting 10 times reductions in inference costs and 65% improvements in response times by switching from closed APIs to open models running on NVIDIA hardware. They're literally returning millions of minutes of lost productivity to physicians. But the really mind-blowing applications are in physical AI, deploying intelligence into robots, autonomous vehicles, and industrial systems. The computational requirements are almost unfathomable. Training a reliable autonomous vehicle system requires simulating tens of billions of driving miles per day in hyper-realistic physics engines. Industrial companies like PepsiCo are using digital twin simulations to model every machine, conveyor belt, and operator route with physics-level accuracy, enabling AI agents to test millions of optimization scenarios and achieve 20% increases in throughput. NVIDIA is open-sourcing the foundational models for all of this. Their Cosmos framework for physical reasoning, their GROOT foundation model for humanoid robots, their simulation platforms, all freely available. They're systematically removing every software barrier to entry for the robotics revolution while guaranteeing that the massive computational workloads will run on NVIDIA data center hardware. Now, let me synthesize all of this into 3 concrete insights that you should remember long after this episode ends. First, commoditizing the complement isn't just a defensive strategy, it's an expansion strategy. By making AI software free and excellent, NVIDIA isn't just protecting their existing market share, they're creating entirely new markets that literally couldn't exist with proprietary software. Sovereign AI, enterprise AI factories, robotics applications, these represent hundreds of billions in demand that requires open-source models to function. Second, the most powerful competitive moats aren't always obvious. Yes, NVIDIA makes the best chips, but their deeper moat is CUDA, 20 years of software ecosystem development that makes their hardware the inevitable choice for AI developers. By ensuring that open-source models standardize on CUDA, they make competing hardware platforms second-class citizens in their own market. It's not about having the best product. It's about creating conditions where your product becomes the only rational choice. Third, when you make a resource dramatically cheaper, you don't reduce demand. You create entirely new categories of demand. This is the Jevons paradox applied to AI. Cheap inference doesn't just make existing applications more affordable, it enables AI agents, robotics, and physical simulation applications that require orders of magnitude more computation than today's simple chatbots. NVIDIA is positioning itself at the center of that explosion in demand. So, what does this mean for you? If you're an investor, understand that the most successful companies don't just build great products. They architect ecosystems that make their products indispensable. NVIDIA isn't just selling chips. They're constructing a future where every AI application depends on their infrastructure. If you're building AI products, the open-source ecosystem isn't just a cost-effective alternative to closed models. It's often superior in terms of customization, control, and avoiding vendor lock-in.
And if you're simply trying to understand the future of technology, pay attention to this pattern. The most transformative strategies often look counterintuitive at first glance. A hardware company spending tens of billions on free software seems like charity until you understand the deeper game being played. NVIDIA's $26 billion investment in open source isn't an expense. It's one of the most sophisticated strategic moves in modern business history.
The next time you see a company giving away something valuable for free, ask yourself, what ecosystem are they trying to create? What future are they trying to make inevitable? What deeper game are they playing? Because in technology, the most powerful moves are often the ones that seem to make no sense until suddenly they make all the sense in the world. That's our deep dive into NVIDIA's open source strategy for today. If this kind of strategic analysis gets you excited about the future of technology, make sure you're subscribed to Mindcast wherever you get your podcasts. I'd love to hear your thoughts. Do you think NVIDIA's strategy is brilliant long-term thinking, or are they creating competitive forces they won't be able to control? Drop me a line through our website or find me on social media. Until next time, keep questioning the obvious and looking for the deeper patterns that shape our technological future. I'm Will, and this has been Mindcast.